Hello and welcome back. In the last video, we had discussed about the degrees of freedom. Today, we will discuss about forces. But before we do that, please ensure that you hit the subscribe button and join us in this wonderful journey of learning structural engineering with staadpro. So, if you remember the Newton's first law of motion, any object in a state of rest would start moving only and only if it is disturbed by an external force or forces. Well, the same would apply for an object in motion as well, and if you wanted to bring it in rest. But we do not need to look into that aspect for now. So what are the various forces that would be needed to move this ball, this weightless ball, along the different degrees of freedom? So for this ball to move translationally in the x direction, there would need to be a force to be applied in the x direction. Similarly, for the ball to move translationally in the y direction, a force would be needed to be applied to the ball along the y direction. Similarly, for the ball to move in the z direction, a force would be needed to be applied on the ball in the z direction. So what would make the ball to move in the rotational degrees of freedom? Well, that won't be forces, but that would be moments. Moment can be thought as two equal and opposite forces separated by a distance d. These forces needs to be parallel. Now this would create a couple on the ball which would make the ball to rotate. So the ball in that case would be rotating about the z-axis. Similarly, a moment can also be generated if this ball is being translationally restrained. It's not allowed to move translationally in any direction, but it's free to rotate. And if you attach a lever arm to that ball and you apply a force in this direction, this would actually make the ball rotate about this axis. So, in both these cases, the moment would be given if the force is F, then, and the force is F in this case as well, and it's separated by a distance d, then in both the cases, the moment would be represented as the product of force and distance. For example, if we open and close a door, we would apply a force at the door handle and the door would rotate about a center of rotation, which would be the point where the door is hinged to the door frame. The moment would be calculated about the center of rotation, which is the hinge point, and that would be calculated as the product of the force and the lever arm. So if the moment is applied about the x-axis, it would be called the mx moment, and this mx moment would cause the ball to rotate about x-axis, so theta x would be created by mx. Similarly, if the moment is applied about the y-axis, it is called the my moment and it would cause the rotation theta y. In the same manner, if the moment is applied about the z-axis, it is called the mz moment and it would cause the rotation of the ball theta z. So like the pure components of motion in space, fx, fy, fz, mx, my, mz are the pure components of forces. So any force that would make the ball move in space would be a combination of these pure components of force. I hope you have understood the concepts today. If you have any questions, please put that down in the comment section. If you have liked this video, please hit the like button and press the bell icon for more notifications from the Structural Insider. See you in the next video. Thank you.